Hey everybody, it's Adam.
Wait, are we doing that? That was really fucking weird. Hi, it's Brian.
So you may have noticed this episode fell in your feed out of order, and it has a strange name, and maybe you didn't. Who knows? I don't know how you listen to podcasts. You do you. But we're launching. We have one of the things that our Patreon community allows us to do is spinoff shows. So the rest of this episode is a spinoff that we're working on as a tank to put all of these engineering conversations in my everyday life now that I'm working with a blockchain company. But it's called the SideChain. And if you're interested in blockchain and cryptocurrencies, we'll be over there having conversations with hopefully other weirdos.
Nice. Yeah, I think this will be a great podcast for your business because all the excitement that we get, all the excitement and goofiness that we bring with Zengineering, I think is important to bring into a professional setting, but it gets lost a lot. So I think this is going to be a valuable side conversation.
And I've found this medium to be pretty effective. We're on episode 53. 4? I don't know.
It's a great way to dive into some awesome conversations with people. It sets a neat backdrop, the podcasting. It sets a neat backdrop for a conversation. Like all the people we've had on as guests, we could have just called and had a conversation with, but it just wouldn't have been the same. You know, there's something about this. It sets up like a framework and an architecture and an expectation and future thought about this being public. And it provides a neat medium for conversation where people kind of are like presenting themselves a little bit. But
also an archive. I go back and I listen to episodes and modify my thinking.
For sure. We're our biggest fans, you know, unquestionably.
So if you're listening to this on the SideChain, thank you for jumping on the SideChain. And if you are listening to this on Zengineering Podcast, I'll share the links through all of our normal channels so you can follow it if you like. It'll be in the description to this video on most podcast players. Check that out.
It's a really neat space. And the more I dive into the tech and the potential opportunities and just everything that's going on with blockchain technology, it's wild. We just can't talk about it every episode on Zengineering. So we're slicing it out a little bit.
This episode will be front to back an example of what one of these SideChain episodes will be like, coming in at about half an hour.
Nice.
Dig it.
That sounds super digestible.
Hey, I'm Adam, your host, and this is the SideChain. It's a blockchain podcast, Zengineering style. We want to talk about how this stuff really fits in your life and what are you supposed to do about it. Like I said, I'm Adam. I produce and co-host Zengineering Podcast. When I'm not doing that, I'm the CEO and founder of a company called Juris. We're working on legal tech solutions in the blockchain space. We're doing pretty cool stuff. If you want to check that out, go to jurisproject.io. Otherwise, on the weekend for the last 3 years, I've been hosting a podcast with my co-host, who you've already heard on this episode, and who is today's guest. His name is Brian Jones. He's CTO at Netwise Data, which is an ad tech company. He's a startup founder, he's a software engineer, and I've known him for 25 years. The conversation you're about to listen to started from the question of whether or not it would be profitable to build a solar-powered storage mining rig full of hard drives with a minimal CPU in the backyard. Or one of our backyards? Your backyard? When it comes to crypto, these are the kind of questions we're going to be chasing with the SideChain. Where's this stuff actually going to show up in life, and what's it going to look like? Subscribe wherever you're listening if you like this, and give us a review or a thumbs up or a heart or whatever it is in the app. If we mention anything cool in the episode, there will be links in the description that will probably appear in the same app. And I can't get out of here without a thank you to our backers on the Zengineering Podcast Patreon campaign. It's that support that helps us keep things like this coming out. If you want to check that out, go to patreon.zengineeringpodcast.com. Lastly, because I gotta say it, none of this is investment advice, Brian and I are involved in crypto. We're working on projects. We're playing with technologies that we're curious about, and we're talking about what we see. If you want to do the same, do your research, and don't risk anything you can't afford to lose, like tomorrow, because the economic side of this is really volatile. Once again, I'm Adam. You can connect with me at the Kerp on Twitter. Thanks for jumping on the SideChain.
I've been reading a lot of white papers. Well, I've been skimming a lot of white papers. I've read a handful for different crypto technologies or different crypto startups or different coins, tokens, whatever you want to call all the different projects.
For the purpose of anyone unfamiliar, the sort of the launching off point for a blockchain system, which is because it's all protocol based, the first thing you have to do is propose your protocol and see if people think it's something they would adopt. And you do that via a 20 to 80 page academic paper where you explain literally everything you can think of about how this needs to be designed. And then you ask people to talk about it.
They're kind of like business plans, but it's the whole infrastructure of these businesses is so technologically oriented that it just doesn't follow traditional business exactly.
But it does follow traditional academic structures, like do a research paper, then take that around, see if you can get a grant to do the experiment outlined in the research paper.
Yeah, interesting.
It's not an unfamiliar architecture. It's just unfamiliar to the public.
Yeah. Well, it's weird because it's being enacted in public, right? It's taking academic research papers to venture capitalists and they're like, wait, something's weird here. And then it's like, but we don't want your cash directly. We want you to buy this weird thing we've made up. Anyway, I've been looking at a lot of those to really understand what's going on with some of these businesses and the opportunities and stuff. They've kind of fallen into three categories. They've been either not particularly interesting or insightful at all. They're just an idea that has like loose, really high level vision for things, which is not helpful. They're not onto anything, or they haven't taken the time to bother explaining it. Or two, and this is a lot like the Juris white paper. It's extremely well developed and very intelligent on the like how it works side. Or number three, it's
product design.
Or number three, it's very, very heavily developed on the tech side, like the actual
graphs
underlying
and
engineering.
Equations and a whole bunch of shit that no one understands unless they went to school for that.
Right. Which is weird because those, I can't understand any of those. And you'd think I'd be able to read through most engineering white papers, but they can be very, very academic. And the Storj one in particular, I think, was that way.
Yeah, so let's back it up. So you just mentioned a specific company, but I want to back up one thing that comes up frequently in our conversation, so I think it's worth mentioning. We, because of how we put this together, I'm sure you've already listened to my disclaimer about investment advice. But when we do think about this stuff, and the thing that ends up impacting how I think Brian and I behave as investors in the space is you can't think too hard about how the technology works exactly. I mean, like before you put money into something, you absolutely should. But the place to start with something that's going to be worthwhile to pursue, whether you're a developer getting involved in a project or somebody trying to buy some tokens to sock them away for later, they fall into verticals. And by verticals, I mean like, here's a sector of a behavior that will probably be impacted by this evolution of technology. And there's like, I don't know, 7 to 10 of them I could run down. This is something that comes up a lot when Kevin Rose talks about this stuff, which I would definitely recommend his podcast, Block Zero, it's called. But one of those verticals is storage. Like literally, where am I going to put the files that I need to save in a function like Dropbox in my life, where I have a folder, goes up into the cloud behavior.
Just cloud, like storage of digital information.
Right. I mean, like local
Dropbox.
storage is easy, right? It's hard drives. Used to be floppy disks.
Used to be floppy hard drives.
But in this space, what we're talking about is there are projects exploring whether or not we can make the service that like Amazon Web Services or Dropbox provides, cheaper, and I think compared to the way we do it now, weirder than what we're used to. But it's happening via this sort of decentralization. So what the specific project you mentioned, Storj is one. Like SIA is another play in the space. There's Filecoin is one that I think is sort of attacking the same problem.
Yeah, those are the
IPFS is the underlying file structure for Filecoin. So before talking about the sort of incentive mechanism piece, I feel like because what we decided we wanted to chase here was, is it feasible for us to try to build a solar-powered storage mining rig to just put in the backyard and make money? So talk through like what you do know about the Storj project, right? Like you mentioned their white paper earlier. You said it's very technical. The technical piece, it doesn't matter. What are they trying to solve? Because they have to get a lot of people to do it for decentralization to work. So like what's their, what's the pitch?
It turns out after
for any of these services.
It turns out after looking them up, I don't think I've ever actually looked at the Storj white paper. I was thinking of the IPFS white paper. But I'm sure the Storj one is also reasonably technical and would require a dozen reads for me to really digest it. But these basically, I think we have to roll this back even a little further for most people, right? Because I get the classic joke these days of like, what the hell is the cloud? What's in the cloud? I had someone make a great joke the other day. I was out playing volleyball. Someone, we were looking at clouds and it was like, it's not cloudy in San Diego. And then someone like really whimsically said it like, is that where all the files go? It was just, it really got everyone. It really laid everyone out. But
that is where all the files go these days. The
may
cloud.
as well be.
Like what? So yeah, you're right. I mean, for most people's experience of this kind of stuff, it's just a tool in their pocket that they use to have a picture that they took at a volleyball game and they went on with their life. But there's this whole substructure of computers and hard drives that make it so that happens, and they live like in a decommissioned shopping mall in San Antonio. But there's a copy of that file that sits on that server, and it serves up my website.
Is that a real place
wherever I go? Yeah, Rackspace.
Oh, they run in a decommissioned shopping mall.
Yeah,
that's
it looks like Hunt Valley Mall from the outside, but the inside of it is just full of servers.
They just tore down the mall by my parents' house where I grew up, and they're going to replace it with a new mall that is just designed to be outdoors as opposed to an indoor mall.
Yeah, that's what they did at Hunt Valley.
Trendy.
Bumps business way up.
So I guess everybody, I think for the most part, is kind of familiar with the concept of you take a picture on your phone and it gets stored on the hard drive on your phone, or whatever the memory on your phone. People kind of get that, right? People know there's storage space. Everyone's storage space is filled up, and they're constantly like deleting pictures so they can take more pictures that they're not going to look at and then delete later. But the idea of the cloud is kind of the exact same thing, except that your phone takes the picture and then sends it to a computer somewhere else. And the cloud is just other computers with other hard drives storing your files. And it gets really complicated. I mean, there are layers and layers and layers of complexity that make that possible and quick and usable. But at the moment, when you do that, if you have like an iPhone, your picture goes up to Apple's cloud. It goes up to Apple's computers somewhere.
And all that complexity that you talked about is like the protocol piece that comes up whenever we talk about this blockchain stuff, because you have to remember that layer when you talk about blockchain projects, because that's where the next compelling layer in this like hitches into the whole thing. But all this complex communication makes it happen. But in the end, what happens is that picture ends up on a hard drive, encrypted, so Apple can't tell what it is, but it's on a hard drive in a somewhere, a geographical location that is a set of chips that are remembering that file and multiplying it, propagating it across other instances so that it won't be lost. And we call that behavior the cloud, because it feels like, whoop, it's up off my device and now it's chilling, but like it's just chilling in a
this is a different hard
on
drive.
A computer. Right.
Well, it's interesting for a couple of reasons. It's interesting because with digital files, digital information, there's no degradation to the file. So your picture is sitting on another thing somewhere, and your picture is exactly the same. It's not like
It's
you're
even
taking a
scrambled
negative.
up, and it still
Yeah, it
is
can even
exactly one for one the same as
it's
like perfectly replicable.
It's like it's broken down into pieces. It's then encrypted. It's thrown around through like layers and layers of stuff like that. Then it's like put back together exactly the same, stored somewhere else, and then in the future you can access it again. It's bizarro stuff. But what's interesting and what kind of leads into this conversation is, as the internet, initially the internet was just like, it's all, you kind of think of it as like the World Wide Web, right? It's computers all over the place doing stuff, storing stuff, I'm accessing things that are other places. But with cloud-based storage, the idea of me putting an image, like taking a picture on my phone and then sending it to Apple, we very quickly, the internet requires that you then like redistribute this stuff. So the internet works in like, just because Apple's hosting my image doesn't mean that when I go to get it, I'm actually getting it from Apple. It's very unlikely I'm actually getting it from Apple. It's probably distributed somewhere. And if it's not distributed across other servers all over the world, it's at least distributed over Apple's servers all over the world. And so none of this stuff works in a centralized fashion now. You can't just put your images on a computer that sits in Silicon Valley somewhere, and the whole world's not pulling their pictures off of like a set of computers just there all the time.
The single computer, right? Because geography is still a problem. Like even if the stuff moves at close to the speed of light, it takes time to get from New York to Los Angeles. Just a tiny bit. But people demand these things load so fast that we actually have networks where what Apple actually owns or pays other people to handle is a copy of your website is sent to 1,000 different locations all over the globe, so they can be geographically closer to the place asking for them.
And it doesn't quite work the way like a letter with the Pony Express works. I don't make a letter, give it to one individual, and have that individual deliver it to the endpoint. It's more like there are a billion Pony Expresses operating at all times, delivering everything in chunks and pieces and layers, and there are thousands of middlemen. And so there's a lot of weird stuff going on that is abstracted and you just don't see, that no one's really seeing on some level, right? It's just sort of computers making decisions as information moves around the planet.
And so then I think where most people would be familiar with this dynamic disrupting things is the music sharing context and the Napster context and stuff.
Music sharing contest.
Sure was a contest. The industry did not fare well.
They didn't like it.
Which is part of the reason there's been this boom in crypto right now, I think, because people look at that and they go, oh no, we don't want to get music industried. We don't want to get Ubered.
Yeah.
So they're jumping on these things now. But where it gets relevant as a sidechain pod like question is, okay, so the solution sometimes to what you're trying to solve here is you just have to put the files geographically closer to the people that need them all the time. That could be a server that's still 100 miles away from you, but it's certainly closer than across the country. Or it could be like literally your neighbor's hard drive. And that's what Napster did. Napster was, well, that's on your neighbor's hard drive, and on the speed of our local network at a college, I can pitch that to you in seconds. Let's do this. Mm-hmm. What storage projects are chasing is the idea that if you can incentivize via this crypto economic component of the protocol, if you can incentivize people to go, yo, I got hard drive space and fast internet that is doing nothing most of the day while I'm at work, I'll turn on X service, give you access to that hard drive space if you'll pay me for it. Because why not? I'm burning resources to make that thing exist on the network.
It's a great social commentary on every technology that we own right now, right? Everything is just being wasted 99% of the time. Those guitars in the background in both of our rooms right now, they just sit there all day. Even if I play a lot of music, they're still sitting there like 23 out of 24 hours a day being wasted. That's stupid.
Well, and that's a really funny interest. Like, and people are sort of attacking that problem in certain context because I have a worse version of that. You know, I own a pair of skis. Those get
Totally.
used every 2 or 3 years.
What a
You know,
waste.
and it's a thing that I still want to own because I have them tuned and I'm used to how they work, and I don't want to break my leg on something I'm not familiar with. Having broken a leg now, I mean it.
Don't want to break a leg. Don't break a leg.
Don't break a leg. It's unpleasant. Even the least possible version of how you can break a leg. So projects like this are popping up, and I've been using one of them, the one you referred to earlier, Storj, which is pronounced storage, but it's spelled with a J. We ended up with this as an idea for something to talk about because I went through all of the installation stuff for Storj, and now I can talk about getting that up and running, and I've earned some money doing it. It helps you take a look at what we're asking people for in terms of buy-in if they're going to take part in this giant network.
Mm-hmm.
And there's certain hurdles that relate to like Zengineering type conversations about interfaces and things like that, right? Like, will people actually do the thing we're asking them to do? Getting paid sure helps, which is the thing that blockchain allows in some capacity. But in my case, I have a computer that I leave on all day in my house. It's very energy efficient, just sitting there doing nothing because it's mostly just asleep. But it's a media server for my house. So if I want to pull a movie that I ripped into a digital file like years ago, so I didn't have to carry my DVDs around anymore, I can get that off of a hard drive in my house that just sits there all the time. And it also backs up all my photos ongoing, which is now sort of a service I don't need because of the cloud stuff we just talked about. But I also have an empty hard drive. So I put that hard drive in there. I installed the client. I had to do some wonky network stuff to get around security. But I'm now taking part in this Storj effort to decentralize this problem of the cloud, which is we need to store this information somewhere for the cloud to function. And so I'm offering up a hard drive. It's all encrypted. I can't see what it is. I can't get into any of the files. I can't do anything with it. I have a little client that tells me how long, what my uptime has been, how many gigs of that allocated space are taken up, and what the transfer speed is of that uplink. And the question then for me is, you get payouts monthly. So I had it running all last month, and I earned maybe $1.75
Nice
worth of their crypto tokens.
That's trivial for you, but someone running a solar powered rig somewhere else in the world, that might not be completely useless to them.
Right.
And you
so
only used a little bit of your hard drive space too, right? Didn't you say like 30?
Yeah, that was only a terabyte, right? So if I put up, I could multiply that, I think, by 16.
Did you use your whole
speaking.
terabyte? Were people using
What?
the thing?
No, only 20 gigs is used. So I assume as more of my stuff gets picked up, it's all about uptime with this. So they allocate files based on the velocity of those files relative to their system. So if they need to move around a lot, I don't get them because I shut it down occasionally to play VR games, which means I have an uptime glitch. But it doesn't mean I'm not getting stuff that's more glacial.
I mean, if you had maxed that drive, if you had been getting used more, you would have made $50 or $100 probably.
I don't know.
Roughly with that math, right? So that's significant. That's a big deal. That's a couple dollars a day.
So what we would need to build, if we wanted to build a solar powered rig to put in the backyard to make it so that I didn't even have to pay for power,
which is a big deal.
Which is a big deal. What do we have to build? What are the pieces that go into this rig? And we were just going to make this up, and then you just told me that Storj actually has plans for one on their website.
Yeah, pretty great. I mean, they have a whole post talking through all the technology, all the different components, pricing out different versions, depending on how much you want to spend, from like really, really inexpensive to top of the line. And then a great discussion
So
of it all together.
So we'll put that in the show notes for sure.
Yeah.
But stop looking at that. Off the top of your head, how do we pull this off in a way where I can plop it in my parents' backyard, which happens to be on a southwest facing slope, which is ideal for catching a whole bunch of sunlight for a chunk of the day? The ideal place to put it would be their roof, but we'll scale up to that later.
Is there a channel for this?
In Zengineering?
Got it.
Oh, yeah. Prefix sidechain.
So I think the first couple of things to address are
we need to have a computer, and it has to live outside.
Yeah, you need a computer of some sort. It doesn't need to be a fancy computer, I don't think, right? It needs like a little Raspberry Pi or one of those. Probably, I'm assuming you need to run Linux or some standard operating system, Windows or Mac OS.
Yeah, the computational function of this is the stuff that I mentioned about monkeying with network settings. Like, that gets way easier if you do it the way that we're describing right now.
Right. So,
but the steps are hackery.
At the moment, you probably need like a regular computer. Although that kind of thing, this is a great application of Internet of Things where we're going to be getting specialized hardware to do these specialized things. So ultimately, you're not going to need a fancy computer. You're just going to have a hard drive rig. People are going to be running hard drive rigs distributed remotely, solar, renewable powered, wind turbine, etc., to generate these
producing.
Things. Yeah. So at the moment, though, you need a computer, a laptop, a desktop that you're not using, something little like a Raspberry Pi that you can go pick up really inexpensively. I mean, you can get a Linux-based computer now for under $10, I think, right? $5. That's incredible. That's absolutely mind-blowing considering what was available 5 years ago. So you need a little computer. You need hard drive space, which at the moment is still going to be just the standard big hard drive that people are picturing if they've ever played with computer components.
So you need some sort of interface, which you can probably buy pretty standardized, that'll hook that. I mean, it's USB, so that'll plug into the computer.
Mm-hmm.
Those all have to have a power supply.
Yep.
To run, as well as the Raspberry Pi.
You'll need a source of energy, plus then a bunch of electronics in between them to kind of regulate and convert and manage that. You'll probably need...
I honestly think the most expensive component of this, like one item per one item, is the Pelican case I'm imagining putting it in. That's probably like $800.
Well, you can probably find a non-Pelican based waterproof case. Certainly in Southern California, you could probably just put a little tarp over it.
So in terms of, I know this isn't your field of expertise, but the hard part of this is actually not that piece. The hard part of this is uptime. So you got to be connected to the internet all the time, which is not too hard if you have just like a cable internet provider, which we do at the location that we're talking about. And we need to make sure that power doesn't go away while the sun is not out anymore.
Yeah, you need.
To me, the most concerning part of this is that we need to run a battery wall of some sort.
Yeah, I mean, the part of the electricity architecture will be batteries, right? You need to, not only are you powering this with solar energy when the sun is out, but I mean, you're probably always going to be powering it off of the battery directly. But the solar panel will be charging the battery when the sun's out. And then when it's not, the battery will be getting depleted actively while the system's running. So certainly I think there are probably more people in the world who could set up the software on this than there are people who could set up the physical hardware to actually power it with renewable energy. I don't think it's any more complicated if you know what you're doing. It's just a much more specialized, less known field of engineering. So certainly anyone who's an electrician could set this up, no problem. And anyone who's a programmer could probably set up Storj, no problem. So bring those two together, you're in good shape.
Right. And I assume that eventually companies will just do that for you, or it'll be incorporated into your Tesla power wall. You also have a Tesla storage wall.
Yeah,
you can allocate as you see fit.
It's a really interesting time period to be talking about something like this because You very much right now could go out and set this up. I would guess at an absolute minimum, bare bones, you could probably, if you just had to start from scratch, go get these parts. I bet you could build this for $100 to $200, maybe less, and have
I think the hardest part is, as I was envisioning it, at least, like if you could do this attached to a house, it gets way easier. If you want it to be like a mobile rig, so you can do like what you were talking about, like just plop it in a village somewhere, and as long as they have internet access, it's money coming in. Weatherproof cooling apparatus is going to be the hardest part. You'll eventually want like water cooled, where the rain actually cools it when it does rain, and in between you use a ventilation system.
I don't think there's gonna be much heat on this system.
Conductive.
I don't know. Heat comes from processing. The actual physical microchips heat up from electrons cruising through them fast enough, the friction of electricity moving through them. And hard drives, I don't necessarily think you'd be processing enough information on the drives for them to heat up. If you had, especially if you had a traditional hard drive with a spinning hard disk, that's going to use more electricity because you're going into like mechanical motion to access, but those don't generate any heat relatively.
But most likely you're going to use solid state.
So if you're using solid state, then you just size it appropriately so it's not hot. I think you'd be fine. I don't think you need cooling on this.
Yeah.
Unless you're like cutting edge solid state.
If it has to be waterproof, is it going to end up being a problem of, because that's going to be tight. There's not going to be moving air in that system. Or any sort of cooling unless you build it in somehow.
I think waterproofing this and making it cooled is pretty trivial. I mean, you could probably build this out of like plywood and caulk, right? Or like put a couple roof shingles on top of something.
Right.
All of the electronic components you can pick them up at anywhere, Home Depot, right? To run stuff from your solar panel into a box. That stuff's going to be cheap. You're just going to use industrial like house components, right? It's not like you're setting up a desktop that needs to be delicately cared for.
Let's talk about the solar panels. Could we do this with a Goal Zero, like the thing you can buy at REI for $400 at this point?
I'm not familiar with that.
The better route to do some sort of industrial.
I'm guessing you'll need more power than whatever comes from the thing you get at REI, because that's probably designed to send a little bit of juice to like a cell phone to charge it, or maybe a flashlight that's built into it or something. So you'd probably need a bunch of those, but I don't really know pricing on solar panels, and I can't off the top of my head. I don't have a gut reaction to like amount of solar square footage you need to power different devices. I'm not that familiar with it, but I doubt you'd need a lot. I would guess you can get a solar panel that everyone's picturing, like a meter solar panel, and you probably have more power than you need to run this device.
Right. So if the answer is you probably need to build a shed of some sort, it certainly seems like the real way to do this is if you have a roof on a house. This is why at a certain scale, obviously everyone should do this. But then on a smaller scale, can we just do this in a backyard and have it at least break even? I don't know, but I kind of want to try it.
Yeah, it'd be hard. We'd have to run some numbers on it. I mean, I'm guessing, no, you can't make money on it yet, or people will be doing it. And especially that's because there are two components to this that are really hard to solve. And the one is electricity, which we're solving, right? We're getting renewable energy is less expensive now than traditional forms of energy. Solar power, wind power, not everywhere on Earth, but a lot of places, the prices of those technologies have dropped. So that's being solved. That will actively have been solved for probably everywhere, almost everywhere on Earth in the next 10, 20 years, maybe, in terms of the technology behind renewable energy is dropping to a point where it makes more sense for everything. Battery technologies have gotten better, and that's all kind of in that electricity aspect of this. The other place where we don't have a solution right now is internet connection, right? We're still locked into massive global infrastructure that has cost incredible amounts of money and is monopolized by a handful of big companies. And I don't say monopolized to pass judgment on it necessarily. It just kind of is the situation.
It's the correct word for the phenomenon of centralized power.
It's the correct adjective for the situation.
Of centralized control.
But we've removed the cost of the electricity in a matter. If you set this up correctly, it might not quite be profitable yet, but it most certainly will be. It's trending in that direction. The internet connection is the component where there's still a cost associated that I'm not sure what we do, right? Because I know here the cheapest internet I can get is like $60 a month, which is ridiculous.
What we do is talk about Starlink satellites on a later episode of this, because, sir, we are out of time. But we did talk at the beginning of our last Zengineering episode about something that Elon Musk is working on to solve this problem. Because if I can just get my internet from a satellite for this rig I'm talking about building, then maybe we solve the problem you're talking about.
Yeah,
that seems to be what I don't know what
Elon his economic Musk goals are with that, chasing. But I certainly think it's to provide internet to people who can't get it and can't afford it, who could be making money doing this. Imagine the resources that you make available to a remote village in Central Africa. You're literally beaming resources to them instead of them having to dig oil out of the ground that might not be there. You're creating a resource that they can now generate wealth from.
In a month of power output at the setup that I have, which is certainly not optimized, I made $1.50 in American dollars in a month. It's trivial to me, but it's something.
It's really exciting. It's really cool, and it's awesome. And I commend you for hooking that up and actually doing something functional with not only distributed technology, potentially renewable energy, and also cryptocurrency. You're doing it. It's not just a stupid number that people are laughing at as they look at their stocks and investments.
Well, don't give me too much credit. Every other experiment I'm running involves having conversations like these on podcasts. But thanks for coming by for this conversation.
Yeah, thanks for having me over here.
Although presenting it like that feels disingenuous because we're just rolling production of the occasional of these episodes into our Zengineering. If you ended up here just because of SideChain, check out our other podcast, Zengineering Podcast. You can find it at zengineeringpodcast.com. We talk about stuff like this, but weirder.